OffTop requires that users have an account with us. That way users can have personalized reports and we're able to perform analysis based on people's location, age, and profession. Our report page provides users the ability to select from daily, weekly, and monthly reports. There they can see the progress from a recording session and view their hearts per minute in the event they have our Future Watch app, as well as their focus score. We even provide a list view summarizing reports and as a navigation to select specific reports. In the front end, we're performing multiple HTTP requests. Our login, for example, utilizes a Spring Boot API that retrieves data from our MySQL database. Here we've created tables that create queries based off of relational data, as well as storing user information. Upon logging in, we are redirected to our main recording session page. Currently, we're viewing our dynamic sub-nav bar, which holds the user's first name as well as the state of the app. For this example, we are on the main page. We have integrated a meter that updates based on the focus score of a user's speech. We've made it intuitive so that when users are getting off topic, it falls into the red, and if their focus is doing well, then they will fall into the green side. Finally, when a user is ready to begin a recording session, all they need to do is click on the recorder icon where they'll be prompted to choose a topic. These specific topics can be set from a list of other topics provided in our settings page. Finally, when a user selects a topic, we'll begin a recording session which sends that topic, the user ID, and the audio data into the WebSocket for a series of computation. So let's record something. Hello, my name is Josh, and I like eating pizza and playing basketball with my friends. Now that we've begun capturing users' audio, we begin sending it into our pipeline from our WebSocket and then into Kafka. Here we can see that our users' audio is coming in as a list of bytes, to soon be consumed from Python and then converted back into a WAV file so that we can transcribe the speech into text and then be sent for further analysis by our machine learning services. We are viewing the initialization of our machine learning pipeline that utilizes Mozilla Deep Speech API to transcribe our speech into text. When complete, we are able to view the newly transcribed text, the time we finished transcribing, as well as the duration required for this process. Next, we begin to analyze our speech. Below, we see that our data has been normalized, tokenized, and marked by named entity recognition tagger, otherwise known as NER tag. We can determine one's focus based off of the data we are consuming from the front end and see which entity appears the most to determine if the user is on or off topic. We see that the sport entity appears more than food, confirming that our user is on topic. Of course, that is our foundational logic. We have plans of making this more sophisticated with other machine learning approaches, such as including decision trees and long-term, short-term memory algorithms. Now that we have our output from our machine learning services, we are storing the data into our MongoDB database, so that we can perform further analysis and have data for user session reports. We are also utilizing Kafka to produce the focus score object back into our data pipeline to be streamed into our front end. Finally, we can see our focus meter updating based off of the focus score that our machine learning services provided to us. So if a user is on topic, we will increment the meter, otherwise the score of the meter will decrease. We have considered how we will notify users when they're getting off topic. In the settings page, users can personalize how they want to be notified of their progress. They have the option of selecting short vibrations, a text message, or an alarm of some sort, amongst a few other notification types. And that, ladies and gentlemen, is how a group of strangers got together to create a real-time monitoring system to determine focus of user speech. Thank you very much.